Hello, thank you for checking out my final winter forecast, 2016-2017. This has been released on November 6th, 2016. These are the factors that go into this winter's conditions. First on the list is ENSO neutral, or a very weak La Nina, both very similar. It's not going to have a huge impact on this winter, and it leaves the rest of the teleconnections in this list to have a bigger impact. Especially the NAO, the AO, the PNA, the PDO, and the Siberian snow cover extent. Other anomalies include the warm temperature, water temperatures northwest of Hawaii, the water temperatures off the east coast of the United States, and the QBO. The water temperature northwest of Hawaii is cold. That is a surprisingly accurate indicator for a trough in the eastern United States, because if you have that, it helps you to pronounce the ridge if you have a positive PNA, and if you have the cold waters, it actually helps the positive PNA grow. So we have that. Water temperatures off the east coast of the United States, they're warm, and that helps storms. And if you can get a cold ring of water around the water temperatures off the east coast of the United States, it helps to foster a negative NAO. The Siberian snow cover extent, not a lot of people know what that is. I have a slide to explain that. And the PDO and PNA have stayed mainly positive, however, not as positive as my update when I made back in July. Hold on. This is the sea surface temperature anomaly map as of the 3rd of November. As you can see, we have a slightly cool ENSO, not much of a La Nina, but an ENSO neutral on the cold side. Over here you have the warm, the cool waters around Hawaii, and you have the positive PNA and positive PDO. And here's your cold water ring that rings the warm water right outside of the east coast of the United States. And what that'll do, as I said previously, will set up a negative NAO, and we have that right now. This is an ENSO neutral winter pattern. ENSO neutral, weak La Nina, they're very similar. You have a polar jet stream which dominates a subtropical jet stream which is pretty weak. I don't see this happening. And Pacific jet stream, which is, it depends because of the PDO. This may not be very strong either, but there will be some Pacific jet stream influences. This is a typical La Nina winter. We're not going to see that this year because it's not much of a La Nina. This is for moderate to strong La Ninas. This is unlikely to happen right now, this exact slide. So a lot of people don't know the impact of Siberian snow cover on the state of the AO. And the AO is Arctic oscillation when it's in its positive phase. It doesn't really affect the United States. Actually, it makes it warmer because the cold air is trapped up here. When it's in its negative phase, the stratosphere is warmer, and the cold air is not trapped up here. Over here is the colder stratosphere, over here is the warmer stratosphere. And when it's negative, it allows cold air to filter through down to the United States. So what happens in low snow cover years is that the Siberian snow cover is less expansive. Warmer surface conditions weaken the Siberian high. Tropospheric jet more zonal, and the weaker poleward heat flux, vertical wave propagation. Stratospheric polar vortex remains strong. Stratospheric circulation anomalies propagate into the troposphere, and positive AO conditions develop in the troposphere. Basically, when the Siberian snow cover is less expansive, that leads to a positive AO. When the Siberian snow cover is expansive, it induces surface cooling and strengthens the Siberian high. We have that right now. It's very cold in Siberia. Tropospheric jet amplifies and enhanced poleward heat flux, vertical wave propagation. Stratospheric polar vortex weakens, and this says like that since the cold air up in the stratosphere weakens, the cold air in the Arctic areas are able to filter down into the United States, giving a negative AO. This is a negative NAO and a positive NAO. NAO is one of the most influential factors into winter conditions. In the positive NAO, a large upper low in the jet stream is over Greenland, which often keeps the heart of the cold out of the eastern United States. When the NAO is positive, pattern favors ridge in the jet stream over the southeastern United States, and sustained cold air cannot move into the United States. The pattern favors Midwest New England, which is a very small area, and the rest of the United States is warm. In a negative NAO setup, a large upper high or ridge, sometimes a block in the jet stream, is over Greenland. This setup means a much colder pattern, as the jet stream is forced to plunge south into the Midwest and the East Coast. And the pattern favors much bigger winter storms for the East Coast. Positive PDO. I've been talking about this for the past couple winters. This is one of the things that help foster a ridge in the western United States. And this is important because without a ridge in the western United States, it's very difficult to get cold air into the eastern and central United States. This is the positive PNA pattern. As you can see, when the warm waters are here, a ridge is formed, and that leads to a trough being formed in the eastern United States, and vice versa. In the negative PNA, it's cold and wet in the western United States with a trough because the waters are cold. In the east and central United States, it's warm and dry. These are my year anomalies for all those factors that I had talked about. These are the years that fit best, and this is the temperatures I've come up with. These are my own observations. I did not take this from anybody this time. Last time I did use somebody else's, but I gave them credit. But this time, this is the years that I see that are very similar to this year, ocean temperature-wise. And as you can see, out here in the west, there is a positive PNA, and just like in most of the years I took, there's a positive PNA because that reflects what we have now, and there's a trough in the east. So, with the positive PNA and the positive PDO, you have the ridge in the west and a trough in the east coast, and there's blocking up here, which allows the jet stream to come up and not just go out, which would not form any storms for the eastern or central United States. This is my final temperature forecast. I'd say, in general, warmer than average from the northwest to the southwest to the southeast, and the warmest temperatures will be in California, Nevada, New Mexico, Arizona, and Oregon. And in these areas, there are temp swings because the ridge and trough aren't exactly going to be in the same place all the time. This is where the cold air will be, as you saw here. I think much colder than average here in the Great Lakes region. Slightly colder than average here because temperature gets moderated by the Atlantic waters, and colder than average in the Mississippi River Valley. Here's a precipitation forecast. Since the Pacific Jet will be somewhat active, I think above average precipitation for the Northwest seems reasonable. Below average precipitation seems most likely from Florida all the way to California. And above average precipitation seems likely in this area because we have the trough. And whenever you get a trough and a ridge in the west, it's very likely that you will end up with more storm activity on the northeastern United States and in the Ohio River Valley. Here are the storm tracks I think will be most likely for this year. I'm going to start with the dark green. Move myself over here. In the dark green, it occurs when the PNA is negative and when we have below average North Atlantic blocking. Provides heavy snowfall to the Sierra Nevada and Rocky Mountains in the central and upper Midwest. This storm track is uncommon. It'll be more likely in the beginning and the very end of winter. but just in general, it's not going to be likely because we have a positive PNA and we have slightly above average North Atlantic blocking. Light green, this occurs when the PNA is positive without much North Atlantic blocking. It brings heavy snowfall to the western and central Great Lakes, somewhat common early on, say in early December, late November. The storm track's already being popped up in the models, but it'll be uncommon January onward because of the Arctic air that we will have in place in the eastern United States. The pink occurs when the PNA is positive with average to above average North Atlantic blocking and ample cold air. Heavy snowfall is produced from St. Louis to Indianapolis to the northern I-95 cities such as New York and Boston. This is the most impactful storm track on the list, and it's going to be common because we will see a lot of storms developing leeway of the Rockies, and they will take a track such as this one. The blue, this is your typical clipper track. Your storm system will come from Alberta, and it'll drop 3 to 6 inches in its path, north of its path. And it occurs when the PNA is positive and when average to above average North Atlantic blocking occurs. It's possible that this storm track can phase off of the coast if the jet stream is angled in the right way. And what this does is it brings heavy to significant snowfall to New York, Philadelphia, and Boston. This storm track is very common, but not the phasing. The phasing will happen several times this year, but the Alberta Clipper will happen very frequently. Based on those observations and those forecasts for the storm tracks, here is my snowfall forecast. I have slightly above average snowfall forecasted in the northwest. This is because we have above average precipitation because of the Pacific Jet. This would be in the mountain ranges. Normally, they don't get a lot of snowfall in Washington where there aren't mountains. They will get, we will get some snowfall in Montana, not from the mountains, because the Pacific, even if it is warmer than average in Montana, if there is above average precipitation, there will likely be some snowfall. And over here, a lot of clippers will come through here, but that's pretty common, so this is average. Above average snowfall in this big dome from, let's say, St. Louis, Missouri, all the way up to Maine. It includes Michigan and Upper Michigan, but I don't show that on the map. This is because of the very frequent storm tracks that frequent this region and off the coast. This is probably this and the well above average area because of the lake effect. That's the most likely above average snowfall there is. So this area is probably the jackpot for this winter because of frequent storm tracks and colder than normal temperatures. Below average snowfall spanning from California all the way to South Carolina, coastal South Carolina. And this is just the lack of precipitation, lack of storm tracks, and warm temperatures. Most of the places in these areas don't get snow usually anyway, so it doesn't make that much of a difference. But some areas do, such as central Texas and the mountain ranges, and this will be below average snowfall for you guys. This is my overall conditions map. It's not as elaborate as the other ones that I've made in the past years, but I don't think I need it to be. Warm and wet in the northwest with heavy mountain snowfall. That's pretty straightforward. You just have the storm systems coming over here and then go this way, and that drops heavy mountain snowfall. Here in the intermountain ranges, you have the variable temperatures with average precipitation, and it's just like the average. Usually these areas, when you have a positive PNA, they will see a ridge out west, so you could see multiple clippers coming this way, but that's normal for you. So variable temperatures, because the ridge will move places. It won't stay at the exact same place all the time, but you will always see the clipper system, so that's why you have average precipitation. Very warm and dry in California, spanning all the way to Texas, and then I don't think it's as warm but it's still dry in the south, in the deep south in Florida. Cold with average snowfall with frequent clippers. This is where the trough begins. You're not going to see very big snowfalls here often because it's downwind of the trough, so it's downward motion. You don't have very big storms that way, but you will see average snowfall because you have your clipper systems. You might see a couple big storms with the dark green storm track, but that's not very common. So in this royal blue area, very cold with above average snowfall, with well above average lake effect snowfall. This is because you will see multiple Arctic air masses coming into this this area of the United States, and what that does with the record warm waters in the lakes, that just creates feet upon feet of snow. So there's going to be a lot of snow for the lakes this year. Winter battle zone in the pink. This is just because you'll have a lot of storm tracks going through this area, and it'll just bring all sorts of wintry weather like sleet, snow, rain, freezing rain. It's going to be a mess over there. You could have some all snow storms, and you're going to have a lot of all rain storms, but it'll just be in the middle. Average between the warm and dry and the winter battle zone. It's just because you will get some precipitation and you will get some cold, but it's not going to be as extensive as the winter battle zone, and it's definitely not going to be as warm and dry as the warm and dry area. And finally, we have cold and very stormy, many major / significant events. That's not necessarily major snow, but just lots of storm systems that will go into this area, and that in turn will lead to above average precipitation, and especially if you have the cold air in place, you are going to see a lot of big snowstorms. So that is my winter forecast. Thank you for watching. Please leave a like, comment, and ask me anything. And I'll try to get back to your comments, and thank you for watching. Bye.